Okay, right. So you guys, should I go forward now?
So,
Okay. Now the other one is a bit trickier than what we have just done now. Now, in case I'm gonna take, I think this space would be enough. So the next experiment is when we have to do finding the specific heat capacity of a liquid. Now, what you do? In that case, what you do is that you need to have a funnel, okay? Sort of a, it's called condenser, Liebig, something like that, right? So it's not like we're not condensing anything. It's sort of a apparatus like this, like that. So in this one, you have basically water in. So this is the inlet, and from this side you will have water out. So we keep on running the water like this. Okay. Now what you're going to do is, again, you're going to put two thermometers on each side. Oh my God! Wait a second. Huh? Keep on snapping. Sorry. Ciao. Okay. So let's call this thermometer one, which is T1. And then you have another thermometer on the other side to monitor at what temperature the liquid is coming out. Let's call this T2. In the middle of this, we place a heater, which is obviously now connected to power, like that. Okay. And naturally, when the water flows, so it's like filling it up, heater is heating, and then when it's heated up, it goes out from the other side. You guys understand the schematic?
Yes.
Okay, please draw this.
So it goes out in the form of gas?
No, no, liquid. We're not boiling anything.
Uh-huh. So, but I don't understand if it's coming from one side, but then how is it leaving from the other side? Like, how is the water out from there?
So suppose if the water comes in with 50 degrees of temperature, the heater heats it up to maybe 60 degrees of temperature. So that's how water comes in. Do you get it?
Oh, okay, yes, sir.
Yeah, it doesn't mean we are not boiling it. This heating coil that you see is basically a low voltage heater. It's always like that because we want uniform heating through the coil. Okay. Get it? Yes, Aman.
I also had the question that when we're gonna put the water in, how are we sure that it's coming out from the other side? Like, what's gonna make it flow towards that side?
Come
I
again,
don't
please.
really
I didn't
understand.
understand.
I'm trying to say is that when you put in the water from one side, and for example, it's 50 degrees Celsius, right?
Yeah.
But how are we sure that it's gonna flow out from the other side? Like, is there a change in pressure or something? I don't understand. What's gonna
Oh no
make
no no
it?
no. You're getting it wrong. It's on the same level. If you look at from the front, right, it will be like this. This is in, and this is out, like that.
Oh, okay, yeah, that's what's confusing me because the one is from like down
No
and
no
the other one.
no. It's like
Okay,
we're looking at it from the top. You get it?
okay, yeah, yeah.
Yeah.
Now I understand.
Okay.
Yeah, so that's what I was asking my question as well, because It looks weird from this side.
No, no, that's not it. We're like looking it from the top. It's like the condenser is like this. Let me just show you a 3D one. It's like this, and then there is one inlet on that side. One like inlet is on that side, outlet is on this side, and basically it's standing like this. Do you get it? So water flows in, comes back like that.
Yeah, so now it makes sense.
Yeah. Now, what is the most important part in this is notice, and this is something when you write it in your P6, you guys need to understand that if you're aiming for maybe the top in your city or country or whatever, you guys need to understand that here there's an important concept that there is no insulation in this. If there's no insulation shown in the exam, it means that there will be heat loss to the surrounding as well. Do you guys agree?
Yes, sir.
Okay. So according to our, you know, wait a second. I've lost something. Wait a second, please. Okay, found it. So according to the energy conservation, the input energy in this is energy supplied by heater will go in energy gained by water, plus some of it is going to be lost to the surroundings. Is it clear? You guys agree with me?
Yes, sir.
So this is the main principle conservation that we've learning since the beginning. So the energy supplied by the heater is dependent on the power of the heater and the time for which you have turned on the heater. So let's suppose we say we want to turn on the heater for 5 minutes. So the energy will be power P1. So we're going to take two readings in this. I'll tell you why this is a clever reason to do that. Power into time will give us the total energy supplied by the heater, because energy is power into time. So you can also write E1 if you want to. The energy gained by water will be the mass M1, the amount of mass. So I'm just writing here. M1 is the amount of mass flowed through tube in time t, whatever time that was. All right. Times the heat capacity of the water, and then the change in temperature. What is the change in temperature? That is T2 minus T1. Is it clear? Okay, you guys. What does C stand for? C is the specific heat capacity. Maha?
There in M1, is it amount of mass flow through?
Yeah, flowed through the tube in time t.
Okay.
Okay. Is it clear? Plus, let's call the amount of heat that was dissipated in the surroundings, let's call that H. We have no other way of finding this. Is it clear? Now, please understand this, all right? In reading 2, what I'm going to do is I'm going to change the power. If I change the power, so let's suppose if I put in more energy, so I need to have a higher power with the same amount of time, which will cause a greater mass to be heated up. Is it clear? In the same time. So M2 is the mass of water flowed through the tube in time t that we have taken. It could be 5 minutes, 3 minutes, whatever you've taken. Is it clear? The heat capacity is a constant value, which is the same for water, so it will stay the same. And why we want greater mass to go through it? Because we want the final and initial temperature to be the same. You guys get it? Now, why is this necessary? Because what you guys need to understand is that the heat loss to the surrounding needs to be kept same. Now, why is this? Suppose we want the temperature to always be 50 to 60 degrees, right? And the outside temperature is 20 degrees. So the heat loss will depend on what is the temperature inside and what is the temperature outside. So heat loss will be like this. So in the next reading, we also want the temperature to be the same inside so that the heat loss is equal. Now, how heat loss changes it? If you have a greater difference in temperature, like there's 100 degrees and 20 degrees outside, so more heat is going to flow. If it's 50 degrees and the 20 degrees outside, less heat is going to flow. So what are we keeping constant is we want the temperature initial and the final every time the water goes in to be the same, so the heat loss to the surrounding is kept the same. Is it clear, everyone?
Yes.
Sir, can you explain it again?
Yes. Let me give you a short review of how energy travels. Okay. Suppose you have, I'll do this here. Suppose you have an object which is 100 degrees right now. Is it clear? The outside
Yes.
temperature is 20 degrees. So heat will always flow from higher temperature to lower temperature. Is it clear?
Yes.
Also, the greater the difference between temperature between two bodies is, the greater the heat loss is going to be. Is it clear?
Yes.
Now, at the same time, if we keep the same amount, let's say there's another object with 50-degree temperature and outside is 20. So, although temperature is still going to go out, like heat is still going to go out, but now the heat will not be as much as the first one because the temperature difference is smaller. Is it clear?
Yes.
Now, when we were taking the first reading right here, I would want to tell you is that at that time, the temperature initial was 50 and it basically bumped up to 60. Is it clear? So
Yes.
the outside temperature is 20, so there will be some heat loss occurring. We have called that H. Get it?
Yes.
Now, in the next reading, I have increased the power of heater. If I increase the power of heater, but I want the temperature rise to be the same. So what can I do? Well, what I'm doing is I'm increasing the amount of mass that will flow through it so that the temperature change remains the same, but now more mass is heated. Is it clear?
Sir, no.
Like what I'm saying is, imagine this. There are two buckets of water. There's one bucket has 2 kg of mass. Okay, Fatma?
Yes.
And then another bucket has just 1 kg of mass, right? If you
Yes.
basically want it to go from temperature T1 to temperature T2, you will apply some heat, right? Agree?
Yes.
When you heat it up for, let's suppose, 5 minutes, it goes from T1 to T2. Now you want basically it to go from 50 degrees to 60 degrees. You understand?
Yes.
Now, if I apply the same amount of heat onto 1 kg, will it be heated quickly or slowly?
Slowly.
1 kg will take more time than 2 kg.
No, quickly.
Quickly. But I don't want to do that. What I want to do is, instead of heating it up quickly or slowly, what I'm doing is I'm reducing the heat amount of heat so that it basically goes through the same temperature in the same time, but because there's less mass and less power given to it, less energy. Is it clear? Like that.
Yes.
All right. Any questions here, Rama, Hamna, Maha? Yes, Aman. Aman, sorry.
Sir, why can we just not add an insulator again?
Okay, the biggest issue is you can add an insulator, but it will not give you 100% correct value because you see the sides are open. Okay, so no matter what, when the water will enter or exit, it will cause some heat loss. You get it? You can
Yes.
add it in the surrounding, but how will you insulate the entry and exit points? You cannot do that, right?
Okay. Yeah.
That's the issue. Now, again, I'm telling you, I took small mass. I I basically gave it energy 1 to heat it from 50 to 60 degrees. Okay. Then for the next reading, I took a big mass. I gave larger energy to heat it from 50 to 60. Is it clear? Do you guys understand? So what I've done, I've changed the amount of energy given to it for different masses. Clear? Should I go forward now?
Yes.
Now the best part of this is that I have two equations, and when I subtract this, you see something very important. E2 minus E1. So this will give me the change in energy. M2 minus M1. This will give me the change in mass, the difference in mass, times the heat capacity times the change in temperature. And if you look at this, the heat loss to the surroundings minus the heat loss to the surrounding in the first one, they will cancel out to be zero, so they will not have any effect when we're finding the heat capacity of the water. Do you get it?
Yes.
Yes.
So this is why we are taking this approach, so that the heat loss to the surroundings is completely cancelled out. So what are we doing? We're taking one set of reading, and then we've increased the power to take the next set of reading, and now we've subtracted the two equations to completely remove the heat loss effect, and that is the reason we will get the most accurate value of heat capacity of water in this. Is it clear, everyone? Yes, Shawez and Rafe. Maha, everything is clear. Hamna, Aisha.
Yes, sir. Yes, sir. It's clear.
Good. So these are the two experiments in this particular chapter. So you just need to remember this. Now, keeping that in mind, then you guys can copy this, and then let's look at some of the questions from the past papers and see what they have in for us. Okay, you guys need to give me like 1 minute, okay? Okay. All right. Now, the good news is that in your syllabus, specific heat capacity is only left. Before that, there was vaporization as well, but for that, now we don't have to do anything. I'm going to put one question here, and then let's answer that. And they've just started the experiment for this one, which is the new one. So, unfortunately, that's bad. Oh, it's not good. Okay. All right, let's have a look. Now, these two questions from the past papers. Right. So, the first one, it says that this is the first one we've done. Shows an apparatus used by a student to measure the specific heat capacity of iron. They have electric heater, iron block, thermometer, and the same thing, and then they've put a material. Now it says the student improves the accuracy of experiment by placing material around the block, as shown. Suggest the name of possible material that student could use and explain how it improves the accuracy. Can somebody please tell me this?
Sir, they'll put an insulator around the block,
Okay.
and this is
What kind of
because
okay?
this
What
is to
insulator?
reduce heat loss to the surroundings.
What insulator should we put? It says suggest. Suggest
Sir, would aluminium foil be fine?
Al- Aluminium is a metal. That would not be fine at all. You put an
Really?
insulator.
Rubber,
Rubber, yes, rubber could be one, and
Okay.
plastic,
you can use glass, you can use cloth, whatever you want to use, other than metals. Okay, don't use that, please. Now,
Got it, sir.
and reason why it's important
It reduces heat loss to the surroundings.
because yes, reduce heat loss to surroundings. Very nice. All right. Then it says state how student could further improve the accuracy experiment more of the material more of the material used in 4.2. Yes, can you please tell me? But this question is a very stupid one. You just need to look at the diagram to tell me why. How can you improve that? Do you remember our drawing? Our drawing looked like this. The insulation was, the yellow one. What is the difference here? What do you guys say? Yes, Abdullah. Yes, Ayman. Aman.
Maybe they could put more insulator around the openings where they've placed the heater and the
Yeah.
thermometer to prevent loss from there.
Yes, so they should put more insulator on the top of it, right? It's just one mark, so you just need to write put more of it on the top, which is exposed, right? So sometimes you will see questions like these. Please refer back to the drawing, it's mostly like that. Anyway, now it says the current in the heater is 3.8 amperes. The potential difference across it is 12. The iron block has mass of 2 kg. When the heater is switched on for 10 minutes, the temperature rises from 25 to 55. Calculate the specific heat capacity of iron. Okay. Now, I'm not sure if you guys have done this yet, but I'll tell you that energy in this one will be calculated because we haven't done electricity, so I'll give you the energy myself, which is current voltage times current times time. So voltage here is 12, the current is 3.8, and the time is 10 minutes. So we got to change that into seconds. So times 60. So I'm changing it to seconds. Mohammed, that is very bad. You slept during the class? So you got energy to 7360 joules. Now, heat capacity is energy per unit mass and change in temperature. So the energy we have is 2730, 27360. The mass of the block is 2 kilograms and the temperature change is 55 minus 25. Can you guys please help me find this? Yes, you can.
456.
Sorry? 4?
456. 56.
56. Okay. And the units are going to be joules
Yes.
per kilogram per degree Celsius. All right. Is it clear, everyone? Units are
Yes.
the most important. Please always write the correct units. Now, so going further, right, to the next question. So the next question is another similar question. This time, this is the typical paper 4 question, which is about writing that we have done, right? So it says there are 2 holes drilled in the iron block. The heater fits tightly into one of the hole and student places thermometer in the other. As you can see, 3D. Now they're saying uh, the student uses this equipment when determining the heat capacity of iron. State the other equipment the student will need, the measurement student needs to take, and the equation used when calculating the value of heat capacity of iron. Now, what I want you guys to do is, I want you to write this up. I want 4 points, because this is 4 marks. Write 4 points uh, for these 3 questions. All right. So can you please do it? And once you've done, I'm creating an assignment on Google Classroom as a classwork. You write it up and then submit it so I can check. You have only 10 minutes to do that.
Sir, when they've shown the heater and they've also labeled the cable, does it automatically mean that it's already connected to a power source?
Yes,
Okay.
that's correct. But you still need to take some measurements, right? So you need to know, you need to write how would you calculate the energy of the heater. So think about it. Looking at classwork for specific heat capacity. Okay, assignment has been created. Even you're not in the Google Classroom group, right? So
Yes. Could you please add me?
yes, wait. I'm sending you. You came from Skype, right?
No.
How did you find this link?
I used my um the the Learners Academy thing. They send me the link on the WhatsApp group.
Okay, okay. I'm sending you the link on the chat. Okay, in this, you can join that.
Okay.
So please do the write up quickly, and let's see. I'm going to check, and once I check your work, then you can go. Okay. All right, guys, 5 minutes. Hurry up, please. See you. All right. Anybody has done? Should I start checking?
So I'm just uploading it right now.
Okay. Okay. One Maha has done it. Okay. Maha, I'll check yours first. So you have said you want to use electronic balance. That is correct. To find the mass. It's good. Stopwatch timer. Good. Insulator. Okay. Then you will have to mass the block. Now, Mahar, always write how are you going to find it? Like mass a block using electronic balance. All right, Mahar. Initial temperature, final temperature, time taken using stopwatch. Okay. Then power of the heater. Okay, that's fine. And then specific heat capacity will be E gram. Now, how would you write this? Please write this way. C will be equal to power times time because energy is not given in your writing. If you had written energy will be equal to power into time, then you can write energy. Otherwise, just write M and change in temperature, which is good. Very good. All right, Ma, do you understand? Okay, so the next. Okay, yeah. So, Maha, you can go now. That's good. Very nice. All right, everybody else, quickly. It's time. You should be submitting now. Okay. Yes, Aman.
Even I've turned it in.
Okay, checking. I don't know why it showed up for Hamna. Okay. You need to measure the mass using electronic balance. You need a time. You need a timer to measure the time, and you need to measure the power. Okay. You also need to take the final initial temperature. The time taken heat capacity will be very good. Excellent, Hamna. That's 100% correct. And Aman. Sometimes just show it. Aman, you've joined the classroom. It doesn't show your name. Why? Are you sure?
Yes, I did.
Aman, 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 Aman. It doesn't say your name.
Maybe you can reload, or either I could then share screen and show
Right.
you.
No, no, I will reload. Okay, now it's there. All right. Aman. Amna, you can go if you want to. Okay, okay, very nice. So, insulator, balance, power source, stopwatch. Student needs to measure M, okay, the temperature T1 and temperature T2, and then Q0 power and time. That is excellent. Very good. Okay, this picture is very high resolution. Please wait. you guys take your, like, if you use cam scanner, it will lower the resolution, by the way. Okay, Fatma. I'm still waiting for Rafe and Shaviz. Shaviz, how long?
Sir, can I leave?
Yes, please. Electronic
Okay.
balance,
Yeah.
watch, insulator as well. Mass of the block using this, find temperature, power of heater, time. Very good. Excellent. Fatma. Fatma, did you receive the workbook that I sent?
Yes.
Okay, print it out, please. All right. Now, all you guys are done. Good. Okay. Uh, Shaviz, I'm waiting for you, and Rafi, I'm waiting for you.
Yeah, yes. I'm just taking the pictures and sending.